Hey everyone, so now in this video we are going to move on to a topic for adding and subtracting called algorithms for adding and subtracting. Now, before we even get into this, we need to essentially define what an algorithm is, right? I've given you this new word and we don't really know what to do with it. So let's just quickly define what this is. So an algorithm is essentially just a procedure involving some steps. So it's a procedure involving some steps, and these eventually lead to an answer. So an algorithm is a procedure involving some steps that lead to an answer. So previously, when we added and subtracted, I gave you a couple of mental strategies. So we talked about partitioning and compensating. But as our numbers get bigger and bigger, and as the demand increases for adding or subtracting, we need to come up with these little procedures, these algorithms, which we can apply to any addition or subtraction. That's really what maths is about. We're taking patterns of things we're learning when we add or subtract, and we're applying that to a bigger picture. So we're going to take the patterns we've seen and we want to apply that to any numbers, right? So before we even get to talking about this, I want to just speak briefly on some features of numbers. So I'm going to give us a number here, 234. So what I'm going to talk about now, hopefully it's a bit of revision on something you would have learnt in elementary school, but all of our numbers are made up of, we can split these into columns, right? And each of these digits in my number represents a different column. So my 4 here, 234, this is in the ones column. So this means that we're dealing with single digits, digits from 0 up to 10, right? Because once we tick over to 10, we enter the tens column. And then as these numbers get bigger, from 10 to say 100, once we tick over to the hundreds, we're dealing with different stages of the number. We're dealing with these bigger parts of it. So we go from 4 to 3 to 2. So as our number gets bigger into the tens, into the hundreds, into even the thousands, we're going to keep separating this into more and more columns. So it's important that when we add numbers, so say when we add, for example, 9 and 2, we no longer end up with numbers that are in the ones column. So here we have two numbers between 0 and 10. These are in the ones column because you can see there's only one kind of digit to these numbers. But when we add them, we get 11. So we get a number in the ones column and we get a number in the tens column. So this is how these numbers sort of change with adding. And this thing that we notice that once we add numbers that increase our digits from 1 to 2 digits, for example, or 2 to 3, these considerations are going to be important when we start thinking about an overall algorithm for adding these numbers. Now, I'm going to start with a simpler question, staying in the two digits here. So question 1, I'm going to add 26 and I'm going to add 66. Now this video is just going to be about adding, And in the next video, we're going to talk about subtracting with these algorithms. So when we add these, we can think of adding our different columns together. So I'd add this one with this one, and I'd add this one with this one. Now, to better visualize this, I'm going to represent these vertically. So here they're horizontal. They go from left to right. I'm going to stack these. So I'm going to say 26 plus 66. And I want to find an answer down here. So from here, I'm going to basically add the digits. I'm going to go down my columns. Because if you look here, I can split these up in the same way with these little green markings here. And I can deal with the ones and the tens. Cool, okay. So now let's think about adding these together now. So, let's get rid of these. In my first column, in my ones, I'm adding 6 and 6. But that's going to give me a 2-digit number. It's going to give me, if I do, for example, on this side, 6 plus 6, that gives me 12. So it gives me a number in the ones and in the tens column. So what I'm going to do, because I want to leave with my algorithm, with my little steps, I want to try to keep these in their column order. So I'm just going to put the 2 here, and this one that I add by going into the tens column, I now have an extra number in the tens column. And I'm going to draw that here. I've shown this little one, this little excess from here, from adding these 2 digits in my ones column. So now when I add my tens, not only am I adding 2 and 6, so 20 and 60, I'm also adding this 10, this little one extra from my previous addition. So I'm going to add 2, 6, and 1, and that's going to give me 92. So with my algorithm now, I have a procedure for doing things. I'm adding the ones column first. Then I am making note of whether the digit answer ticks over into double digits to see whether I'm considering an extra number in the tens column here. So once I have that, I'm moving along the line. So I'm going from ones, I'm going to my tens now, and considering this extra 10 that I got from my previous addition. And I'm working along the line. So I have now an algorithm that when my numbers get bigger, so here I'm just dealing with 2-digit numbers, but as they go into the hundreds, the thousands, the tens of thousands, I'm going to have a good system all the way through for working with these. Now, let's do another example. I'm going to take, let's do this one. Let's do a slightly trickier one. I want to find 439 plus 172. I'm adding these 2 numbers, and I'm going to color code these again just so you can really distinguish between the ones, the tens, and the hundreds in this case. So I have my ones here. I have my tens here. And I have my hundreds now, because this is an even bigger number, right? So now I'm dealing with the hundreds too. Now, what I'm going to do with my algorithm, I'm going to write this vertically. I'm going to stack these numbers on top of one another, because this actually helps me to visualize the spacing between my ones, my tens, and my hundreds. I'm dealing with this nice and vertically. It's just an easier way to kind of see what's happening here. And once again, I have my hundreds, I have my tens, and I have my ones here too. That's why I spent so much time in this intro really sort of separating each of these digits, because I want to work with these one at a time. So in adding this, I'm going to do my ones first. So when I add 9 and 2, I get 11. So the digit here, my 1, let's try to really separate that. The number in my ones column is going to go here. But you notice I have an extra digit, this extra 1 that has to go in my tens. So I'm going to draw that here. So that means that when I add my tens, I have to consider, when I add my 30 and my 70, or my 3 and my 7 in this column, I have to also consider this little 1 up the top here. So once again, I'm going to add 30, 70, and 10. Or if I look at the separate digits, 3, 7, and 1. So if I add, for example, 30 and 70 and 10, I get, these two give me 100, and then plus another 10, I have 110. So I have a 10 here, and this middle digit, this 1, is going to go here. And we have to consider also, I have an extra 1 over here. I have an extra 100 that I need to consider. So I'm going to add this to here. Now, finally, when I add these through, my 4, my 1, and my 1, I end up with 6. So finally, I'm given an answer. I have gone through systematically, so step by step in my algorithm, and I have added each of my columns separately. And this idea of carrying the 1, that comes out of this idea that I have, in this case, I had an extra 10, for example. So that had to be considered when adding my tens column. The same way I had an extra 100 here, so this 1 I had to consider up here as well. I'm adding an extra 100 in this column. I'm adding an extra 10 in this column. So as we go step by step, this algorithm makes it easier for us to add these bigger and bigger numbers. And we can even move into 4 digits. Let's just do one more example. Let me just think of one in my head. Let's do 2,317 plus, let's go 4,053. Let's do 52. Okay. So writing this one out now, I'm not going to draw all the columns in because hopefully you've gotten the idea of it from the previous example. But if I write this in like this, horizontally, that's always going to be my first step. Vertically. It's always easier to write it vertically because we can distinguish between, we can separate our ones, our tens, our hundreds, and our thousands in this case. So let's look at this one here. And I've actually included an example where there's not as much carrying over. So what I'm going to do, instead of this, I'm going to add a 9 just to spice this up a little bit and practice what we've been talking about here. So 2,397 plus 4,052. Now, I want to add my ones column first. 7 plus 2, I get 9. And you notice here, this number stays a one-digit number. 7 plus 2 equals 9. There's no number in the tens column here. So I just write that, I read it straight off, and then I add it down the bottom. Now, with our second part, I have, let's color coordinate this, my 9 adding with my 5 in my tens column. So when I add 9 and 5, I get 14. So I consider my 4 in my tens column, and I put it here. 9 plus 5 gives me 14, or 90 plus 50 here gives me 140. So I have a remaining 100 that I need to consider here. So I'm going to put that up the top here. So exact same thing we've been doing, guys. We're adding 9 and 5. The digits to the left, I write down the bottom, and I carry the 1 over. Now here I have 3 plus 0. Let's color coordinate one more time. We'll have to do this 2 more times actually. But 3, 0, and 1. So I'm effectively adding 300, 100, and well, there's just a 0 here in the column. So 3 plus 0 plus 1 just gives me 4. And I don't have anything else to carry over here because my number hasn't exceeded a digit. So when I add, for example, 3 plus 1 plus 0, that gives me 4. There's no extra digit here that I have to carry over up here in the same way that we got with this one here. So my algorithm accounts for these types of things. It accounts for this carryover when we add a digit. Now, finally, I'm just plussing my 2 and my 4. Or I'm adding 2,000 and 4,000. That gives me a 6 here, showing 6,000. So my final answer, even for these bigger numbers, these 4-digit numbers, I'm given 6,449. And we get this carryover thing happening with my algorithm. It's going to work for these really massive numbers or smaller numbers too. It's a kind of one size fits all approach that we can apply to these bigger, harder calculations. Because if we did these 4-digit numbers, like in example 3, we can still use our partitioning and our compensation strategies, but they're going to take a long time still. And it's going to get a little bit harder as these numbers get bigger. So we want a kind of blanket big strategy for working with these big additions. And we can apply that to small ones too. So that's it for adding, and we'll talk about subtracting in the next video. Thanks so much for joining me.